All right, today we're going to do analyzing lines of fit. All right, here's your state standards, your success criteria. You need to be able to use residuals to determine how well lines of fit model data. You need to be able to use technology to find lines of best fit, and you need to be able to distinguish between correlation and causation. All right, today you do have a lot of vocabulary. Again, vocabulary is so important in math. If you don't understand what the words or the questions are asking, it's impossible to be able to get the right answer. So just understanding the questions comes from learning and studying the vocabulary. So lots of new words today, so make sure you get these in your notes and make sure you refer to these when needed and also review them so that you can commit them to memory. All right, so a residual is the difference of the y value of the data point and the corresponding y value found using the line of fit. A residual can be positive, negative, or zero. And we will look at what these are with examples a little bit later, but right now, make sure these get in your notes. All right, a linear regression. You can use technology to perform a method called linear regression to find a precise line of fit called a line of best fit. This line best models a set of data. If you watched the last video from the last lesson, you've seen me write an equation using this linear regression model. All right, line of best fit, the line that best models a set of data. Your correlation coefficient. So technology will often give you a value R called a correlation coefficient. This value tells whether the correlation is positive or negative and how closely the equation models the data. Values of R range from -1 to 1. When R is closer to 1 or -1, there is a strong correlation between the variables. As R gets closer to 0, the correlation becomes weaker. So you can see when R is in the middle, that's when the scatter plot has dots all over and there's no correlation at all. But if it gets closer to -1, you're going to have that strong negative correlation. That just represents it would have a negative slope. And if it's close to +1, that means it's got a strong positive correlation, means the line would be trending up and it would have a positive slope, but the correlation would be very strong. Interpolation, using a graph or its equation to approximate a value between two known values. Extrapolation, using a graph or its equation to predict a value outside the range of known values. And causation, when a change in one variable causes a change in another variable. All right, example 1, using residuals. In example 3 in section 4.4, the equation y equals 10x plus 6 models the data in the table shown. Is the model a good fit? All right, so if you watched the last video, you would see that I did this example, but we're going to look at it in a little bit different way. So here's talking about residuals. You can see here's your line of fit. If your data point is above or below, that's what creates the residual. So you can see this has a residual of +3. This one would have a residual of -2. So a residual can be positive, negative, or 0. And that just represents how close it is to the line of fit. All right, so I believe in using technology when you have it. And we have this handy thing called the TI-84. And I use this often, especially with scatter plots and stuff. And I believe in the real world, you're going to have technology. So I don't know why my calculator wants to jump around the screen. But anyways, I'm going to show you how to do most of this using your calculator. Okay, so it says, here's our X, here's our Y. This is the same table from the last example, if you watched the last video. All right, my equation was slightly different because I put these numbers in my calculator and let my calculator write an equation where the example here, they actually just picked 2 points off the graph to do that. All right, for some reason, my calculator really wants to be right here. So I'm going to show you what I have in my calculator. All right, so if you go to Stat and you hit Edit, and I showed you this in the last video, but the table is here. So you can do Stat, Edit, you can enter the table. We'll try one more time. There's the table. I just entered that table in my L1 and L2. X is in L1, Y is in L2. All right. And then I turned on my scatter plot so I could see the points. So I turned my scatter plot on so I could graph it and see the points. Okay. Now, if you go back to Stat and do Calculate, you can do a linear regression, 4, and then just hit enter through. You've got L1, L2, and then calculate. This gives you that linear regression. All right, so one step further. If you want to graph this line, like I did, if you want to graph this line on top of your scatter plot, you can go to y equals, I've already got it here, so let's clear. Go to y equals, and then you're going to go vars, number 5, statistics, come over to equation, and what it will do is copy the regression equation that you just made using your table of values with your calculator. It's going to write this equation in there, and when you hit graph, that's that line. So you can see the line of fit is going to show up right on top of your scatter plot. So what good is that? Now I can do second table. It gives me a table of values, my x's and y's. So if I want to come over here and find out what my residual is, I can have, I can put my y value, well, let's see, y value from model. All right, so if we look at the y value for 0, 0 is 7. And then I've got 17. This is closer to 27, so let's do 17, 27. And then for 3, let's scroll down, make it a little easier. 3 is close to 37, 37, 47. That's a 4. All right, and number 5. Let's round it up to 57, 67, 77. Okay. All right, number 7 is 77, 77, and 86. Falls below that 0.5 there, so that's why I rounded down on this one. 86.4 would round down, where all of these are above 0.5, so I rounded up. All right, so that gives me those values from the model. Okay, so these are the actual points given. So if we want to find the residual, we just have to subtract. All right, so your residual all right, the residual would be 9 minus 7. So 9 minus 7, or 2. This one would be 21 minus 17. 21 minus 17 would be 4. And then 26 minus 27 would be negative 1. It's a minus sign there. Boy, my handwriting is getting terrible. I'm so sorry. Let's see if I can fix this a little bit. All right, 20. Let's see if I can make my pen a little bit smaller. Maybe that will help. All right, let's see, we were at 26 minus 27, so -1. 33 minus 37, so that'd be -4. And then 43 minus 47 minus 4. 53 minus 57, -4. 71 minus 67. 71 minus 67, so that'd be +4. And then 76 minus 77, -1. 89 minus 86 would be +3. So you can see all those residuals kind of fall there. You could graph that. I'm not worried about graphing that. It says, is the model a good fit? Looking at your calculator, if you graph this, you can see that this line goes very close to all of those data points in the table. So you can say that this is a good fit. Also, if you hit calculate again, this shows you that the R is very close to 1. 0.99 is about as close to 1 as you can get without being exact correlation. So this model is a good fit. But if you want to find the residual, okay, this is how you find the residual. You take the difference from the Y value in the table, from the Y values from the model, and all you do is subtract to get that residual. If you're in my class, you're always going to see me use the TI-84 to do this because that is the easiest way to do that. So if I were you, I would make sure I write down the steps in my notes of how to use the TI-84 calculator.